So these last items that we need to name are a group of compounds called the acids. So naming acids. No. Now about these groups called the acids, we see that they have a couple of common features. One common feature is that all acids always, at least for our purposes now, will contain hydrogen. So they always contain H+, and that H is a +1 charge. Right? And another thing that we know is that we're still going to use crisscross, so I'm going to write continue to use crisscross. Good? Now what I want us to do is I want us to draw two lines off of this. I want us to draw a line right off of the term or the fact that these are acids. So our lines, I want us to have something like coming down this direction and this direction. And I want us to write that you could have one type of acid where you have the H+1 with a nonmetal. And here's when you have an H+1 with a polyatomic ion. So these are the two cases of our acids. Two different styles of writing out the formula. When you have H with a nonmetal, and you have H with a polyatomic ion. Good? Let me show you an example. Let's put H, which is 1+, with chlorine. What's the charge on chlorine? 1-, so you bring those numbers down, they're both 1, are they not? So that would just be HCl. And here's how you name it. You always use a hydro prefix when you have H with a nonmetal. So here it is. This would be hydrochloric acid. You'll see it's got that hydro prefix, correct? That hydro prefix means that it's going to be the H with just a lonely little nonmetal. Ic ending acid. Cool? Let me give you another example. H is 1+. What about S? What's the charge on S? -2. You bring down the numbers, the charges, and you get what? H2S. Is this H like before? You see how it was with a little nonmetal, the Cl? Is this H with a nonmetal? And just one of them? It is it not? It's with the little, it's with the only nonmetal here, it's with the S, it's the little s. Agreed? So we would name this with a hydro prefix, hydro sulfuric acid. Notice again that we've got that hydro prefix working for us. The ic ending, of course, the acid. The hydro, the nonmetal acid, if you have H with a nonmetal. Okay? So the rule maybe we would want to write off to the side as like a remembering technique is that you always use the hydro prefix, hydro blank ic acid. That's the rule that I think of in my mind. Cool? Let's look at the opposing side, and here's the rules for the polyatomic ions. I'm going to write this up top. You take the 8 endings and you change them to X, and the 8 endings you change to us, OUS. And I'll show you how that applies in just a second. 8 changes to IC, 8 to us. Let's look at this example real quick. I'll give you one. Let's put H with NO3. The charge on NO3 nitrate is 1 minus. So when you bring these numbers down, you get what? You get just HNO3. You can tell that this NO3 is a polyatomic ion. These guys on the left did not have polyatomic ions. We use the hydro prefix. We won't use that here. What is NO3? What's its name? Nitrate. And 8 becomes what? So instead of nitrate, it would be nitric acid. Now before you ask the question, I'll ask it for you. And that is, well, what about hydronitric acid? Why not the hydro prefix? We were doing that a while ago. The hydro prefix is when you have H with just a little nonmetal, one nonmetal. This H is with a polyatomic ion. It doesn't use the hydro prefix. How about this next one? H is 1 plus. It's always 1 plus. It's always in front of acids. That's why we wrote up top, acids always contain H plus 1, right? H1 plus. Let's put it with SO3. And what's SO3's charge? 2 minus, right? And then let's bring those numbers down. We're still doing crisscross as we did the day before and the day before that. Normal crisscross. So what formula did we get here? Very good, H2SO3. Now, are we going to use a hydro prefix here? No, because the hydro prefix was when we had H plus with nonmetals, right? We don't have an H plus with just a little nonmetal. We have it with a polyatomic. So what is SO3? Give me its name, please. Sulfite. And what does ite become? Us. 8 is ic, ite is us. So this would become sulfurous acid. Make sense? So really the key part to this, in my opinion, is when you mix everything up, when you have a mixture of stuff. So let me show you with some examples down here, and then we'll see what we got. And copy these down real quick. So if you copy down these real quick, and why don't you start working on solving them, and we'll check them in just a second. Hydro rule or not? Would we use a hydro rule for this one? We would? We would not use the hydro rule, correct? Because this is H with a polyatomic. This first one fits that set of rules over there, right? HNO2, what is NO2? Nitrite. So this would be nitrous acid. Did we use a hydro prefix on it? No, right? No need to. How about in this case right below it? H3N. Is this a case 1 or a case 2? Is this an H with a nonmetal or with a polyatomic? This right here with the N? That's H with a nonmetal, right? So what rule do we use? The hydro prefix, right? Hydronitric acid. Do we see those differences in my decision to use the hydro or not hydro prefix? How about H2CO3 up here? Is that an H with a polyatomic or H with a nonmetal? Polyatomic for sure. What is the name of this polyatomic ion? Carbonate. And what was the rule? 8s go to X. That's the rule for when you have polyatomic ions with your H. So this would not be carbonate acid, this would be carbonic acid, which of course is the acid that we would find in sodas, carbonic acid. Little bubbles in soda. The next one, hydrofluoric. Is this H with a nonmetal or H with a polyatomic? Nonmetal, because we use that hydro prefix when we have H with a nonmetal. What nonmetal do you suspect it's going to be with? And what is fluorine's charge? And since it's an acid, it always has what in front? H plus. So we bring our numbers down. HF. Right? How about this next case? Hydrosulfuric acid. Is this an H nonmetal or H polyatomic example? Polyatomic? It's a nonmetal because of the hydro prefix, right? What nonmetal do you suspect it is? And what's sulfur's charge? And what does every acid have with it? H that's plus 1, right? Bring these down, we get H2S. It's perfect. And then the last case real quick. Sulfuric acid. Is this a polyatomic rule or H nonmetal rule? And what does it come from? 8, right? This is from sulfate, which Maria just said was SO4. What's its charge, Maria?
2.
Minus?
Yeah.
And what does every acid have in it? H, right? That's 1 plus in front. Always you've noticed the H has gone in front the entire day today. You bring down your 1 and your 2 and you get H2SO4. H2SO4. So we see today that we have 2 rules about naming acids. The first case is, do we have an H with a polyatomic or H with a nonmetal? 2 different rules, but very simple. What do all acids contain?
H.
They'll always contain an H plus, right? And then H plus is going to go in front. And you saw it in each case, it going in front. There was never a time where it didn't go in front. It always was there. So you're looking for the hydro prefix and all of your stuff. If you see a hydro prefix, you know you got H with a nonmetal. If you don't see a hydro prefix, you got H with a polyatomic ion, and the 8 ic I us rules will apply. Good?